Welcome to the SimKB. Today, we'll delve into the art of nurturing seeds to sprout and flourish into vibrant plants. We'll explore the essential conditions for germination and growth, along with the care needed during this crucial stage. Get ready to discover the secrets to fostering healthy seedlings. The objective of this simulation is to teach you how to establish thriving crops in a controlled greenhouse environment. This involves learning about seed arrangement, soil preparation, irrigation system setup, and adjusting lighting. You'll gain hands-on experience without having to leave your living room. The evolution of greenhouses has greatly impacted modern plant cultivation. Early greenhouses allowed us to control growing environments for the first time, which led to the development of the advanced systems we have today. These modern systems allow us to grow crops year-round, regardless of external weather conditions, and to control every aspect of the growing environment for optimal plant health and yield. Today, we'll be sowing 3 types of seeds: beans, tomatoes, and sunflowers. Each has its own unique requirements and characteristics, providing a diverse learning experience about different crops in a greenhouse setting. A greenhouse, also called glasshouse, is a building designed for the protection of tender or out-of-season plants against excessive cold or heat. Germination is the sprouting of a seed, spore, or other reproductive body, usually after a period of dormancy. Now that you know about germination, we must try to provide the right conditions for germination. Let us help our seeds germinate and grow. To start, we must first ensure that the greenhouse temperature is maintained within the recommended range for your seeds to germinate. Inspect the seed packet and look for plant-specific guidelines for temperature requirements. Did you read the plant-specific guidelines? Now turn towards your right to check the heat and temperature of the greenhouse. Locate the electric board in the greenhouse, which controls the heat and lighting. If required, you can use the board to adjust the heat and the lighting conducive for your saplings. In this simulation, the heat and the lighting are already in optimal condition. The optimal conditions for plant growth in a greenhouse usually involve a balanced mix of light, temperature, water, and nutrients. The specifics can vary depending on the type of plant. For instance, some plants might prefer cooler conditions, while others need warmer temperatures. It's important to research the preferences of each plant type to ensure optimal growth. Several factors can affect the germination of seeds. These include the quality of the seeds, the depth at which they are planted, the composition of the soil, the amount of water they receive, the surrounding temperature, and the amount of light exposure. In some cases, certain seeds may also require specific treatments before they can germinate, such as a period of cold stratification. To monitor the temperature of the greenhouse, you may need to use the thermometer on a regular basis. Some seeds germinate well in a proper well-lit area while a few other seeds germinate well in dark. Ensure that the germinating seeds receive the recommended amount of light per day, as specified on the seed packet or plant-specific guidelines. Water is the source of all life. So, you must check the moisture level of the soil in your garden pots regularly. Let us now water our saplings to maintain the moisture levels. Now grab the spray bottle and spray water gently over the saplings on the 2 pots, ensuring the soil remains consistently moist but not waterlogged. You just saved the saplings. Please keep in mind that you must avoid overwatering, as it can lead to rotting of the seeds or seedlings. If the soil feels dry, water the pots as needed to maintain the appropriate moisture level. There are a few types of watering techniques suitable for different stages of plant growth. One is misting, which is ideal for seeds and delicate seedlings. It helps maintain high humidity levels necessary for germination. Another is watering from below, where trays or pots are placed in water-filled containers, allowing the water to be drawn up through the drainage holes. This method is good for established plants as it encourages root growth downwards. Lastly, we have traditional top watering, where water is poured directly onto the soil from above. This method is suitable for larger and more mature plants. For our simulation today, we'll be using a spray bottle for misting. You already used it earlier to maintain moisture levels for our seeds. Adding labels or markers help you keep track of the different plant varieties and identify them as they grow. Let us take labels or markers from the label box. Now place the labels or markers in each garden pot near the saplings or sown seeds. Great job! You have learned how to provide the right conditions for the germination of your seeds and how to care for the germinating seeds in the greenhouse. Indeed, there are more advanced methods for plant identification beyond simple labels. Barcode technology, for instance, can be used to create unique identifiers for each plant. Image recognition software, on the other hand, can identify plants based on their visual characteristics such as leaf shape, flower color, and overall growth habit. These technologies can greatly enhance the accuracy and efficiency of plant identification in a greenhouse environment. Yes, methods like hydroponics and aquaponics can be more efficient for seed germination and overall plant growth. Hydroponics is a method of growing plants without soil, using mineral nutrient solutions in water. Plants grown hydroponically are often healthier because they receive an ideal balance of nutrients. Aquaponics, on the other hand, is a system that combines conventional aquaculture, raising aquatic animals such as snails, fish, or prawns in tanks, with hydroponics, cultivating plants and water, in a symbiotic environment. This allows for reduction in water usage, less waste, and faster plant growth.